Have you ever had that feeling that maybe the universe behaves differently when you're not looking? It sounds kind of like a late night dorm room question, right? But it's actually one of the deepest, most profound puzzles in all of science. And it's a question that really pushes us to the absolute edge of what we think we know about reality itself. Well, it turns out that when you zoom all the way down to the tiniest scales of reality, things get really, really weird. Down in the world of quantum mechanics, little particles seem to exist in this strange, ghostly state of all possibilities at once, but only when we're not observing them. The second we try to look, reality just seems to, well, it snaps into a single, definite outcome. And this right here, this is the single biggest mystery in all of physics. It's called the measurement problem. I mean, why? Why does the simple act of looking at something fundamentally change it? Why does our observation force it to, pick a side? To really get this, we have to wrap our heads around a core concept called superposition. So forget thinking about a particle as some tiny, solid ball. Before you measure it, it's way more accurate to picture it as a wave of possibilities. Almost like a ghost that is simultaneously here and there and everywhere it could possibly be, all at the same time. So what this means is we're living with two completely different sets of rules. In our everyday, classical world, a coffee cup is on the table. That's it. It has one location. But in the quantum world, until you actually check, a particle is in a superposition of all of its possible states. This clash, this is the very heart of the measurement problem. How do you get from that fuzzy, blurry wave of possibilities to the solid single reality we all experience every day? So, back in 1957, a physicist named Hugh Everett came along and proposed a solution. And it was, it was breathtakingly simple, but also completely and totally radical. He basically suggested that we've been thinking about this whole thing completely backwards. Everett's idea was this. What if that wave of possibilities never collapses at all? This is the many worlds interpretation. It says that when a measurement happens, reality doesn't pick just one outcome. Oh no. Instead, the entire universe branches, creating a separate, parallel reality for every single possible result. So in one universe, you see the particle right here, but in another universe, an equally real version of you sees it over there. Okay, I know what you're thinking. That sounds like something straight out of science fiction. But what if I told you there's an experiment, the most famous and honestly the most baffling experiment in all of science that seems to show this branching in action? Let's talk about the double slit experiment. The setup is actually super simple. You just fire particles, let's say electrons, one by one, at a screen that has two little slits in it. And then behind that screen, there's a detector that just makes a mark wherever each electron lands. Easy enough. So just think about it for a second. If you're shooting these things like tiny bullets, one at a time, what should you see on the back wall? You'd expect two simple bands, right? One lined up behind each slit. I mean, that's just common sense. But that is not what happens. Not even close. What we actually get is this complex pattern of many different bands. It's called an interference pattern. And that's a pattern that can only happen when waves overlap and either boost each other or cancel each other out. But wait, how can a single particle, fired all by itself, create a wave pattern? It's like each particle somehow managed to go through both slits at the exact same time and interfere with itself. And this is where the physicist David Deutsch comes in with a truly mind-bending explanation. He argues this pattern is exactly what you'd expect to see if many worlds were real. He says the particle in our universe is actually being nudged and deflected by ghost versions of itself that exist in nearly identical parallel universes. So it's not interfering with itself, it's interfering with its counterparts across the multiverse. Now, Deutsch refines this whole many worlds idea in a really crucial way. And this isn't just some small philosophical tweak. His idea actually solves some of the biggest problems with this theory. See, the standard way of thinking about many worlds is that new universes are constantly being created, splitting off from ours every microsecond. But Deutsch says, no, that's not it. He argues that all universes already exist. They're always there, running in parallel. A quantum event doesn't create new worlds. It just causes these pre-existing, almost identical worlds to diverge and go their separate ways. And this perspective is just so elegant because it neatly solves some huge problems. First, the energy problem. I mean, where would all the energy to create infinite new universes come from? In Deutsch's view,
You don't need any new energy because the worlds are already there. And second, it makes that weird interference we see in the experiment a real physical interaction between particles in different but very tangible realities.
So, okay, what's the big takeaway here? This isn't just some abstract theory for a whiteboard. Deutsch argues we might already be harnessing the power of the multiverse with some of our most advanced technology right now. I'm talking about quantum computers. These things can solve certain problems exponentially faster than any normal computer we could ever dream of building. And how do they do it? Well, Deutsch claims their incredible power is basically direct evidence that other universes are real. They aren't just working fast, they are performing computations in parallel across a staggering number of realities.
So here's how he imagines it works. When you give a quantum computer a really hard problem, it basically outsources the work. Versions of that same computer in countless other universes all perform parts of the calculation at the same time. Then, the results from all these parallel computations interfere with each other, just like the particles in the double-slit experiment, in a way that cancels out all the wrong answers and amplifies the single correct one for us to read. It is literally parallel processing on a cosmic scale.
So, look, if this theory is even close to right, it means reality is infinitely larger and stranger than we ever imagined. Every choice, every possibility is playing out somewhere. And that leads to one final, really deep question. If countless versions of you exist across this multiverse, each one making different choices, living different lives, what does that mean for your own identity? Who exactly is the you that is here right now watching this?